Wojciech Mazur. I'm a Scala tooling engineer in Virtus Lab, and welcome to my talk. As I said, I'm part of the Scala tooling division in Virtus Lab. We make a lot of very amazing stuff, which includes like Scala Clay, which you could see in the previous talks by Krzysztof, but also like integration with methods, commercial support for the client migrations. And last but not least, we make actual contributors to the Scala compiler itself. And actually, that's what my team does. And today, I would like to tell you something about one type of improvements that we wanted to add to our testing of the Scala compiler. Besides that, most of my free time, I'm also like maintaining the Scala native, so this amazing project that makes me very excited, which gets rid of the JVM in the world of Scala, and I really like to work on that. But without any other hesitation, let's begin. So, in general, if you come here to know how to test actually millions lines of code of your user commercial products or anything, sorry, that's not very talk about that's not a topic of today's talk. Instead, we would talk about how the Scala is tested. So how do we, for example, make sure that the new version of Scala would not have any type of regressions, source incompatibilities, or binary incompatibilities? We did not have enough time to get a very deep dive into each of the possible aspects of testing. But I would like to show you especially the one thing that we as Virtus Lab wanted to contribute, which is an improved community build. If you didn't know what it is, I will explain it in a second. But first, let's begin with describing how Scala, especially Scala 3, is tested on every change, basically. So here, basically, we have three main components. First one is MIMA, so well-known, checking for binary compatibility, especially in terms of standard library, which is for Scala 3 is quite small, but it exists. And of course, the public APIs of the compiler. So, for example, if you produce a new compiler plugin or use some internals from that, and you don't want to have some binary compatibilities or some changes between the versions. However, that's not the main topic of today's talk. Because we would mostly focus on the source compatibility. So making sure that that each version of Scala can compile the same code as its previous versions and give us the same output. In my opinion, that's what's the most important, for example, when we're migrating or upgrading your versions of library to the latest versions. So let's start with the first very important stuff, which is Vulpix. Vulpix is our internal framework that we used to test snippets of Scala code. So in general, there are like thousands of files that are structured in some kind of way. And we test them with new version of compiler. In general, we, for example, make sure that the given code snippets compiler, or they, for example, fail with the correct errors. That's quite important also. And basically, they are also used for regression testing. So whenever new regression is found, it was minimized, it is added to the set of these Vulpix tests, and it would be, from this point on, always tested on each change to the compiler. So we might be almost sure that the same bug would never happen again. In total, there's like, I think, over 7,000 of different tests. This might include like very simple single-file tests, multi-file, multi-stage, when you, for example, because sometimes if compilation happens on multiple compilation units, so for example, when you use an output of one compilation in the other, then something might get broke. And also like integration with code produced by Java compiler. So, for example, we can be sure that integration in the both ways always works correctly. And in general, they might take up to 1 hour to execute fully. I mean, with Milion version of compiler and then executing all of them. They're nice, and basically they can be a bit treated like unit tests for the compiler. So we have some very well-known inputs, we have some very well-known outputs, and we just want to make sure that it works as it should be. However, unit tests, as always, are not the same as the actual real projects. So that's why we also had in a Scala free compiler and also in Scala 2 a community build. That was a project that was a long time ago introduced by Lambent. That was also kind of framework that was using our real libraries like akka, Zio, Scala test, Scala checks, basically all the main components of the Scala ecosystem, and was trying to build with newest version of compiler. In total, if I remember correctly, there's almost 3.5 million lines of code in only these 70 libraries. For Scala 2, I think it was a lot more. I think it was about 220 different projects. So that's a quite large of code base, which basically becomes a battleground for the Scala compiler. Because in general, everything that we can compile with Scala is somehow a test for the compiler. Because, for example, if something compiled with Scala 3.0, it should also compile with 3.01 or 3.1 or any newer versions. Of course, in general, source compatibility of Scala, especially in Scala 3, is not guaranteed. It might be broken between the minor versions, so for example, between 3.1 and 3.2, but it's probably only going to break some a bit minor things. For example, the wildcard that is using for types, for fire-handed types. And that's mostly just to make some place for new features, new improvements that might use these small source incompatibilities a bit better. And in general, this compatibility is split into like 3 stages, run in parallel, but in general, they take around 3 hours. They are great for actually for finding new regressions, because that's a real code, something that is really used and test multiple interactions and some very clever ideas that were introduced in these projects. However, currently there is almost 1,100 Scala free libraries listed in the Scala Dex. So these 70 libraries actually make about 6-7% of the total coverage. So that's not very much. And also that's one thing that we have seen, that many regressions we could find in libraries that were not listed in the community build, and things that has worked in previous versions of Scala 3 started to fail. Of course, that's just an iceberg, because it's something broke in these libraries. Similar patterns, similar usages might be also present in the projects that depend on these libraries. And that's a real problem, because even though typically libraries would stay on the, would be a bit more conservative in choice of a Scala version, so to be able to address as many users as possible, the actual real-life projects would probably stick to the latest versions. And that's basically what Scala compiler teams suggest basically to do, especially when the LTS support for Scala comes to life and in one of the next major releases of it. The second problem with this community build was the fact that it needs maintenance, especially in terms of updating the list of the projects and listing them at all, ensuring that the configuration is correct and the projects are up to date, because we are just using some stable fork of the library at some given revision that was, for example, not updated for a month or something like that. But and maintainers, creators could introduce some new ways of interacting with the language, which might work in the previous version of language, but fail in the newer ones. So that's quite dangerous, and we wanted to eliminate this. That's why we wanted to create kind of a bit extended version of the community build. This one that we have here is tested on every change to the compiler. So every time a new change is introduced, compiler team needs to wait estimately an hour to make sure that everything is correct. So that's why we introduced this new component, and we called it the Open Community Build. And we have three major ideas that we wanted to have in it. So the first feature of it was to make it as inclusive as possible. So every open source library that there is currently on the market can be easily tested. And not only that it can potentially be included, but we want to make it inclusive in a way that even the creators of the library, maintainers of Scala compiler, don't really need to bother about explicit marking it to be included. By default, anything any library that we can find, which was at some point published for Scala 3, might be a project that we would test. Second thing, because that we wanted to make in it, was to make this new Open Community Build asynchronous in a way that we didn't want to block compiler team to get the results. We all of us have some limited resources, so we couldn't even wait a long time to get all these 900 projects that are available that we might, for example, build, and wait, for example, all day just to get the results, because that would be very wasteful, especially for the time of these engineers. So we wanted just to execute this Open Community Build either on the demand. For example, if we introduce some quite dangerous change that might break something and we are not sure, we want to test it, or in nightly or weekly builds that would just run automatically, and we can just check have in this week something broke or that did not. Last but not least, we wanted to make it easily maintainable. So, for example, we wanted to automatically detect the latest stable versions of libraries, and especially the revisions, so the commits at which they were released, so we can actually reproduce it and compile at this stable state using the new other version of the compiler. Besides that, we wanted also to, for example, detect the JDK that should be used, and, for example, memory resources. So, for example, how many memory we need to allocate for that given build, so it would successfully compile. And after some time, we've got to some initial drafts, which we then a bit extended. And finally, we have come up to a system somehow that basically have some four main components. The first one is the coordinator, which you can see here in the center. In practice, it's a Jenkins instance because we use it just to coordinate all the work on the Open Community Build. And Jenkins on its own is later maintained by the Jenkins operator, so or also known as a Cartago, because there was some kind of renaming shenanigans recently. And it's a product of Virtuous Lab that actually is a Kubernetes operator and makes sure that our Jenkins instance is happy, safe, and working always reliable. Anyway, so that was the first very important component. Second is the planner. Planner would be a component that would create a build plan for our build. So if you would need to know about what kind of Scala 3 libraries are available, you need to get some information about it. And we will talk about it in a second. Third component is our own private Milion repository. So we didn't only want to build the projects, we also wanted to use, at least whenever it's possible, to use the artifacts of the compilation of the building these libraries to make sure that not only the source compatibility is preserved, but also the binary and the stuff that we output can be actually consumed in other compilations. And last, there is our database in which we would just store some kind of logs, summaries, any kind of data that we can then use, query, create some kind of reports, get the logs to find out what went wrong, etc., etc. Keep a history of a project or even statistics of our builds. So anyway, these are the four main components, and let's start to talk about how it actually works. So whenever the build starts, the coordinator requests a build plan. So it basically creates a job in the Kubernetes that starts to fetch data about the available Scala libraries. For that, we use only one source of information, which is a Scala text. And as I said earlier, it lists around 1,100 projects. So that's a quite big number. Finally, we can use from that around 940, I think, because some of the projects we cannot make them compatible currently, or they have some build errors, some misc artifacts. Anyway, some reasons that force us to filter them out from the build. However, as we have this list of projects that we potentially can build, we need one important information, which is versions at which it was published. This, again, information we take from the Scala text. It has all the information about each of the submodules of a given project with the corresponding versions. So we can find the latest one version here. However, just having this version is not enough, because we wanted to build a given project library at its stable version. By stable, means that it's either a final version of a project, or it's a release candidate or a milestone. Why? The question is quite simple, because with such a big number of projects that we built, we wanted to limit the amount of false negatives. So if some builds are unstable, we didn't really want to pollute the results with their flaky results or anything like that. But getting this actual stable release was maybe not such trivial, because we need to assume one very much important thing, that each version, published version, has at least one corresponding tag within the GitHub repository. And if that's correct, and for most of the libraries that's true, then we would try to map this latest version to the latest tags. If we found tag that corresponds to a given version, so for example, we have a tag v100 and a version 100, then it's a match, for example. In that case, we can use the revision of this tag, and we will build the project at this given commit. Of course, if you would not find this information, we would then, of course, use the default one. But at this point, the total amount of unstable builds should be relatively low, so that shouldn't be a big problem at this point. However, just having the information about the version that you should build is not enough. We also sometimes might need an explicit configuration. For example, we need to know which version, minimal version of JDK is used by given project. As you can assume, some projects might, for example, use an APIs from, for example, JDK 17, where I think there was some introductions to sockets, for example. And so we needed to provide this minimal version. Currently, we limit the version that can be used to only LTS versions of Java, so 8, 11, and 17. And only these three versions can be used. And the actual version that should be used can be even provided by the configuration, because I haven't speak about this yet, but I will soon talk about. We would try to find this from either the configuration of given library, Or we would try to detect it from GitHub workflows, for example, basically by just static analysis of the sources. We typically can find some Milion version that should be used and which actually works correctly. As I said, there is also like this configuration file. In the long term, we wish that the open community build would be really a community-driven initiative. By this, I mean that we could cooperate with maintainers of libraries in a way that they will provide configurations for open community build in a form of configuration file at the top level of the project with information, for example, which version of the case should be used, how many memory allocate, some specific SBT commands, for example, that should be started. And for example, that the maintainers of the library would actually tell us, for example, should we test their library fully, so execute the test, only compile because, for example, they use test containers which are not available, or if we should disable testing their library at all, so not even compile their test sources. But at this point, we might help ourselves with our internal configuration. But if you would like to help us in making this community-driven initiative real, then later I will show you some guides how to do it. But anyway, as we would get this information, we know what to build, at which version, which revision to build, and how. We have one more step, which is getting the dependencies of projects. As I said earlier, we have this private Maven repository to which we publish artifacts. And because of that, the order in which the projects will be built is important. Because if the dependents of the given library would be built, I mean, the project that depends on the given library would be built before the dependency is started, then we would not be able to find these artifacts. I mean, it's not always possible that we will actually find them, but we wish to increase the chances of that. By that I mean that we will build the library in the latest version, but projects that depend on it might use, for example, older version. So the guarantee that the binaries artifacts of the compilation will be used are not guaranteed. However, we wish that it will be fulfilled, especially because a lot of projects actually use stuff like Scala Steward, which automatically updates their dependencies. So nowadays, it's quite a big chance that we would actually have a kit. So based on these dependencies, we will create a graph of dependencies, which can be later translated into a set of stages, where each of the stages contains only libraries that are for which all the dependencies have been already built. So for example, stage 0 would contain projects that have no dependencies, and stage 1 would contain projects that have no dependencies, that depend on the project from stage 0. So that's, I think, quite straightforward. Anyway, as we have this full build plan, we'll give it back to the coordinator. And at this point, coordinator would be actually responsible for making sure that the actual builds are actually started, dispatched, and for collecting their results. So we have some kind of pool of worker nodes to which these works are dispatched. Again, we are working in the Kubernetes cluster, so all the resources management is held by the Kubernetes itself. And we get to another point. Inside these worker nodes, we have to actually build the actual libraries. And that means that we need to interact with our build tools. There are actually 2 build tools that are actually supported. And so that's SBT and Milion. And they are used in 99% of all the projects. So that was pretty straightforward why we choose them. And in each of them, we have some kind of abstraction onto the usage of their internals, especially in the usage of evaluation of some given tasks. Because when you run it from outside, for example, when you standard SBT and you just run a single task, you only have these publics as the API. But from within the actual SBT plugin, for example, and from within the actual task implementation, you might get to underlying unsafe API, which is used internally by the SBT, which can be then used, for example, to start actual task and to wait until some given task is ready and get its result. And that's basically what we did. We created some kind of this facade, I would say. So some task that we can run from the outside, for example, running the actual build as a script. And from the inside, we would have all this kind of special logic that evaluates the results, collects the results of these tasks, and runs all the sub-modules of the end project in order. So in terms of SBT, it's quite straightforward because SBT, even though it has a kind of mixed reputation, I would say, then it's it's a very good build, my opinion. At the end, it allows for a lot, especially in terms of its internal API. And it's quite flexible because just to change the version of the Scala version we use, we just use this plus operator, and it happens basically. However, working with Milion, even though it's very loved by the users, from the side of the tooling was a bit more problematic, I would say. So in general, Milion is immutable by the design. So the only way, for example, to change the Scala version that would be used is to modify the sources. And that's not very trivial, I would say. And it's very error-prone if you want to modify the sources of the build. After some time, with the increasing popularity of Milion, we decided to add finally the support for it. And we decided to actually modify the sources of the builds that Milion uses. And we did it with the help of ScalaFix. So we just were checking the actual AST from the Scala source and detecting the stuff that should be changed, for example, Scala version that is used, and we were then replacing it with our own values. Does it work? Kinda. I mean, in the most projects, it works. Sometimes we can find some build errors that are quite rare at this point. But anyway, somehow it works. So anyway, in both of these builds, we would, for each of these submodules, we would try to evaluate the tasks like compile, which would compile the main sources, test compile, so compiling test sources, execution of the tests, so the executing of the actual runtime tests, and finally we would typically build a documentation, so an additional test of Scala doc, and publish these artifacts to our private Maven repository. And basically, when we finish of that, as I said earlier, we would collect the results of all these evaluations of these tasks, and so we would gather some kind of summary, and along with the logs of the given project, we would index all of that to the Elasticsearch. Then later, for example, when all the stages are finished, we would, for example, create some human readable report, so we can have a quick peek into like what went wrong. We would have actual links to logs, so we can investigate even further. And so we can, for example, later use it a bit later in the tooling. So let's put, so now as we know how it basically works, let's take a look at the numbers. So in general, currently we are testing around 940 projects, which covers almost 7.5 million lines of code of tested code base. So that's why I didn't lie about the name of this talk. We actually test millions of lines of code. However, it's not our code. It's the community. The second stuff is the coverage. So now, as I said earlier, in terms of the old community build, we are having coverage of around 6-7%. and it was getting lower because new libraries are published. Now it's around 85%, and we are also trying to improve it even further, but not always possible. In general, building of these projects takes around 20 hours, so that's why you can understand why we wanted to make it asynchronous, because that's not a one big monorepo in commercial project. It's an open source, and we want to make the CI smooth and not block anyone on that. However, all of that allowed us, for example, to find 12 regressions just in the first run. And thanks to that, all of these regressions has never been published. So no frustrated developers, Scala developers, and we like that actually. However, as we might of course know, just finding a bug, that does not mean that we would automatically create a bug fix. That's actually quite a long process. And let me just give you a quick talk about how we actually deal with these found regressions, failures in the open community build, and what looks the journey to fix them. So at the very first step is listing the projects that have failed. So like in here, you can see that, for example, some projects using Zio Cassandra have failed, some Scala Pi module, etc., etc. Most of them actually, like you can see, are failures in the tests. And in fact, that's a very common thing, because especially in terms of libraries that were recently published and don't have any type of configuration that would say, are they safe to actually execute in places where the environment might not provide some types of programs, applications, resources. Without this information, the test would simply fail. For example, we've had a library that integrates with some kind of database. Without this database, all the tests would fail because we don't allow for test containers. That's quite common. Also, there's a bit of problems, for example, when some libraries actually check the actual, for example, when the libraries try to abstract over compilation of the Scala. So, for example, if they have some kind of modules that try to run a compiler and, for example, parse the errors that they found, in that case, there also might be some slight differences because, for example, the actual message of the error has changed. But in most cases, after checking what was wrong, we can, in most cases, either disable the test for a given project or disable one problematic one. But in general, because we have limited resources, we would just simply stop testing. Stop testing the given project, by which I mean that we would compile its tests, but we will not execute them. So that's important. Second most common problem when filtering these failures and trying to find a clue what actually went wrong are the build errors. Actually, for example, now as we are testing, for example, nightly versions of Scala 3.2.2, the configuration that is here taken from some SBT build would fail. Every time we try to evaluate, it would fail with an illegal argument exception because the given build was not future-proof. And that's a problem when this this configuration is not exhaustive enough, or when this handling is a bit too general, I would say. The simplest fix in here will be just to match for the major version of Scala instead of for Scala 3 and leaving the minor version as a wildcard. But anyway, if you find some problems like that, we unfortunately need to disable the given project from the community build, and hopefully in the next releases it will be fixed. Other type of problems are, for example, missing artifacts. And we basically have two type of problems in here. One is, for example, usage of compiler plugins, which are not really supported at this point. And we're working on that, but since they need to be fully cross-compiled for each version's compiler, and because the POM files of the published artifacts does not contain information about used compiler plugins, because we simply cannot detect in an efficient manner which projects use compiler plugins and at which version. Because of that, we also, if we see problems like that, unfortunately, at this point, we need to ignore them, and filter out the projects in the list. But in the future, hopefully, it will be fixed. But anyway, if you went at least to this point, and the given project has not failed either to the failing tests or the build problems, it means that we actually found some interesting piece that might be actually a regression. So let's look at the logs of one of the libraries that we have found. That's actually a Breezy library, which started to fail in one of the nightly versions for quite unknown reasons for us. Of course, only from the logs, we couldn't really think reason what actually went wrong. So what's very important at this point is to actually open the code base, find what went actually wrong, and try to reproduce the actual failure. Typically, we would use Scala for that because we can test on many different Scala versions to check if the regression also happens in the older version and the current one. And for example, here's an example of the reproduced build. It's very important to make them completely standalone. I mean, they shouldn't use any external libraries because later, as the given regression will be fixed, this code will be put into the Vulpix framework. And Vulpix framework basically uses the Scala C command to compile actually the given program. So it should be completely self-sustained. Actually, that's a very interesting issue that you have found here, because actually, until this point, I had no idea that you can actually inherit the default arguments of the method. So you can learn a lot also when trying to reproduce some of these errors. When we find it, we of course need to find a commit that changed that leads to this regression. And for that, we have another dedicated tool. So we have, again, a Scala CLI script that is multi-staged. At the first stage, we only test the published nightly versions. So it gives us a very quick feedback about in which range of commits it has failed, because nightly builds are published every night, and they contain commits, last commits of their builds. So from that point, we can narrow this range of the failing versions of the compiler, and then find the actual cause of the regression. In this very example, Martin Dalski has fixed one regression, but unfortunately, he introduced another one because we are all just people, and that's basically how working with code works. You fix one bug, and another one shows up. So at this point, if you know who to blame, we can actually create an issue, assign the correct persons, wait for the actual fix, and hopefully it will be ready soon. And then, for example, some fixes can be backported if in the meantime new release candidate has showed up. However, as the whole process of reproducing the builds takes a really, really long time. Depending on the complexity of the given problem, it can range from a couple of minutes to a couple of hours. And that's a lot. And no team has enough resources to work on that. We don't have any dedicated quality assurance position that would only be responsible for trying to find these regressions. So here's a proposal for everyone that actually would like to be involved in the process of improving Scala 3. So we've created a tracker for the regressions. One can basically find a list of projects that we have not yet minimized. And if you click there is a version of which it fails. You would find some additional data, some quick guide that will help you to reproduce the failures, and would contain a link to the actual logs of the project. And then we would be very, very grateful if you would be able to help us for example, to minimize these problems. Then the actual Scala engineers can actually work with what they are the best for that. So to improve the language we all love. Also, like recently, I have published this article, how to be part of Scala's open community build. And if you publish a library, it has a couple of tips that maybe you can adapt in your library that will help us to test it a bit more easily. Last but not least, why don't you contribute to the compiler yourself? Of course, we don't want you to jump these deep waters. There are some initiatives that actually help with that. For example, Scala Center organizes these periodic pair programming sessions where you can learn something about the compiler and fix actually something. So if you would be interested in that, you can message Anatoly and he will give you all the feedback. And also, maybe you didn't know, but there is a channel on the YouTube, the Scala Free Compiler Academy, where also these people that involved in the Scala Free Compiler share the knowledge and, for example, show something about the internals of the compiler. So if you'd like to place your first steps in the compiler and contribute to that, that's a very good place to start. Anyway, we come to the very close to this talk, and there's of course one question that we need to ask: does Open Community Build eliminate the regressions from the compiler? As can you guess by this iceberg on the left, no, it's not yet eliminating ultimately all the regression from the compiler. However, it helps with it a lot. As I showed you a bit earlier, 20 regressions just on the first run. We have whole list of, I think, 12 possible regressions they have found that because Scala is a very advanced language, its compilers are real monsters, beasts. Of course, we want you don't want you to discourage from that, but sometimes they are very difficult. And fixing one problem often creates a dozen of new ones. And these type of initiatives, like we have this Open Community Build, helps us to find these regressions early. So you as a developer would not need to bother about choosing the version of the Scala to use, would not need to ask, hey, would this new version of Scala would break my build or can I use it safely? We just want you to just upgrade to the latest version of the compiler of the Scala and use it, because it should be basically treated in the same way as any kind of library, basically. As you upgrade the libraries, you just want to pick the latest one, you didn't use it. But I hope that with the effort of the community, we can just make this effort going. And basically, that's all I have prepared for today. And now I think the time for the questions. So thank you for today.
Hey, thanks so much for your wonderful talk today. We do have a few questions, and I'd love to jump on in. So our first question is, the binary compat of libraries, though requires the library author to do the right thing, is this correct?
In general, the perfect world, every library author would follow the semantic versioning, and he would always also apply its rules to the versioning of its own library. However, in the real world, we know that that's not always happen. Some authors do follow the semantic versioning, others do not. So in general, for us, when testing your library in the Open Community Build, it does not really matter. So we would test the latest version anyway. Because what's the most important thing for us is the source compatibility of the Scala language itself. And this should be basically preserved through all the versions up to like Scala 2.7 in most of the cases, in most of these basic core features of that. So in general, binary compatibility is not that very important when testing in open compatibility.
Great. Our next question is, how many false positives community builds produce? So something reported as a regression bug, but not a bug in the compiler itself.
I would say that it depends. I mean, in general, whenever you create an issue, a new issue in the compiler, and you think that something might be a bug, if you are not sure, we would typically try to answer, is it follows the syntax, the actual specification of the language. And sometimes it happens that we will find some kind of false negatives in a way that, for example, end marker. In Scala 2, a variable named end was a completely normal variable that you can use anywhere, basically. In Scala 3, especially I think since Scala 3.2 or 3.1, it might actually cause some problem because we are approaching this phase when we'd like, for example, to merge the fewer braces, about which some people are excited. But in general, false positives, it's hard to tell. If we would filter out, because in general, when we check which builds failed, we mostly focus on the compilation errors. And in that area, I think that there's between 10 and 40% of null false negatives. It completely depends on a given build, because in some, when there's, for example, a lot of new libraries that might be using, maybe all of them might be using some internal compiler plugin, then maybe all of them will fail and we can't really do anything about that. But in general, after reporting some bug, it would be checked by the compiler team, maybe even by the Martin Dersky, to check if it follows the specification, or is it a real bug, or it simply is no longer source compatible, and we have to live with such an error. I hope that it will help a bit with this question.
I want to say yes. Let's go to our next question. Is there a UI to see build runs, enabled projects, disabled projects?
Partially. I mean, we have a UI because Jenkins on its own has its dashboard, so you can see the results of the builds. And if you would go for this link to the regression tracker, you will find a link to the actual instance of this Jenkins. And if you will just try to pick a bit, work with this a bit, you will find the actual dashboard with all these actual runs. But I wouldn't say it's very readable at this moment. But however, in the future, we would like to create some actual decent, customized dashboard that would actually enable and disable some projects, and to have some real feedback, what is going on, and some real dashboard. So not yet, but partially it's there. Okay, actually I have lost the sound from me. However, I can see the question. So when it comes to the open community build stuff, I'm at this point the only person responsible for that. Also, like most of the regressions that were found were actually reported by me. And there's also like this, I'm not sure if you're actually talking a question about this open community build or the one that is embedded in the Scala compiler. But in both cases, I think that that's a one person, and I don't think there would be any increase recently, because at this point, maybe if we would start to actually to boost the work on the UI of that, but besides that, I don't think there will be any increase or decrease.
Thanks so much. Sometimes we just forget to unmute ourselves, so Thanks for being flexible on that. And thank you for answering all of the wonderful questions that were asked and for being here today. I hope you enjoy the rest of the conference, and we'll see you again soon.
Thank you. I enjoyed very much. See you next time.
Fire in retro rock.
Roger, Matt. Ready to eject.